reusable test cases. Okay, it is a dynamic in nature, not static. Okay, so that's why we are using the SystemVerilog. Okay, and is SystemVerilog synthesizable or not synthesizable? Can you tell me? Is SystemVerilog synthesizable or not synthesizable? Synthesizable means what? We can generate a design. Non-synthesizable means we cannot generate the design. We cannot. It is meant for only test bench. Okay. So now tell me.
Maybe no, ma'am.
Maybe no.
Not synthesizable, ma'am.
Okay. Any other answers?
And as we are going to use test benches in SystemVerilog, so it may not be synthesizable.
Okay. See, SystemVerilog is used for synthesis also, not only for test bench. It has some keywords, some constructs to use design. Okay, it has some advanced constructs to use in design also, not only for test bench. Okay, we'll see what are synthesizable constructs in SV, like logic. What is mean by logic? What is mean by logic means, suppose if you take a Verilog test bench, okay, in Verilog test bench, how you will initialize the value, how you will declare the variables, like you will declare module name you will write, and reg inputs you will write, and wire output you will write, right? Why you are declaring inputs as a reg data type? Why you are declaring outputs as a wire data type? Can anybody tell me in test bench? In test bench, why inputs all are declared with the reg data type? Why outputs all are declared with wire data type?
As we are applying inputs, they have to be stored and should be applied now. Whereas the output is being continuously changed for giving different inputs. So we are declaring it as a net type, where we are taking inputs as a variable type.
Okay, so inputs here we are storing. Okay, like inputs here we are storing the data, and inputs are written in the initial block also, which is a procedural assignment. Whenever you are using the procedural assignment, the output, the RHS side values, LHS side values must be declared with the reg data type, right? That's why inputs declared with reg, output no need to store the output data here, continuously they driven. So output as a wire. So here we are using two type of data types to declare inputs and outputs. But in place of that, SystemVerilog has only one data type called logic. By using logic, you can declare whether inputs or outputs, whatever. Okay, just in place of reg and wire, we are simply putting logic. It will help for complex programs. If you take a like a project level, there will be lot of inputs, lot of outputs. We don't know. It is somewhat difficult to keep reg and wire. We need to check everything. So simply we can put logic in that. Okay, so it is a synthesizable. Logic is a synthesizable, and reg, short int, long int, bit, byte, all these are synthesizable. And we will use in the always block, we will use always com for combinational logic circuit, always ff for flip flop, for latch. Okay, these are like replacing the always in the Verilog. Okay, by using this, we can do very efficiently. For flip flops, automatically it will generate like a register. If you take always ff, okay, it will. If you take only combinational, automatically it will tell, okay, this is the combinational logic circuit. But if you use only single always, we don't know whether it is generating a combinational or sequential, right? So that is the difference. Did you got my point? And next one, type def enum struct union. You already know, you learn in C language, same as here also. But in finite state mission, we can use these SystemVerilog keywords. Okay, and case, you know, case X, case Z, which are non-synthesizable. Okay, we can do synthesize, but the circuit will won't generate by using case X and case Z. Okay, like a break, continue, do while, fork join. Okay, in SystemVerilog there will be fork join all, fork join none, fork join one. Like that, packed arrays. Okay, in Verilog you will have only one-dimensional array or two-dimensional array, but here we have packed arrays, unpacked arrays, like that, dynamic arrays, associative arrays, like that. Okay, so these are like benefits of SystemVerilog and which are synthesizable. Have any doubts? Have any doubts? Okay, coming to the non-synthesizable constructs. So non-synthesizable is nothing but whatever we are writing in the test bench, all are non-synthesizable only. We cannot use those things in the design. First thing is OOP. There is a main advantage of this SystemVerilog. It is a class-based verification. Okay, and the class and objects. You know what is meant by class and what is meant by object. Object is derived from the class. Okay, mailbox, semaphore, queues. You already know what is meant by queue. One type of like array type. That is not array. It is different to store the data. And dynamic arrays, associative arrays. Dynamic array, you know what is the difference between static array, dynamic array, and associative array? In Verilog, we have only static array, but in SystemVerilog, we have dynamic array, associative array. You know what is the difference between both?
No, ma'am.
No. Okay. Dynamic array is nothing but we can change the size of the memory. Suppose I have taken a memory with a fixed size, static memory with a 5 locations. Okay. So I require more memory according to our requirement, according to our program. I require some more memory. Okay. So I can use dynamic memory allocation here. Okay, directly. That means I can resize the memory here 5 to 5. I can make it as a 10. Okay, that is how we can change the size. I'm not telling the program wise, I'm just giving the theory part only in the session. So we can resize the memory according to your requirement. That is nothing but dynamic memory. Okay, coming to the associative memory, it is very advanced than dynamic. How means, suppose I don't know how much memory it is required to my project. Okay, I don't know how much memory I want to take. I'm using somewhat n bit size of memory. Okay, some star. This is unknown memory I'm taking. So whatever you are taken some size of memory, after your functionality, after your completion of functionality, it will allocate the size automatically. Automatically it will allocate the size. We no need to take some size, and we no need to resize like that. Okay, by default, whatever the memory we have used, automatically it will assign the size of the memory. Did you got my point?
Yes, ma'am.
Okay. If you don't understand anyone, please tell me, I can repeat again. And protected retrained task function. In SP, we have advanced task and functions compared to the Verilog. Okay, fork join, as we discussed, parallel block. In Verilog, we have only fork join, but here fork join any, fork join none, all, like that. Like me, threads will be how the threads will be executed. That is what. Next, clocking blocks. Clocking block is nothing but in Verilog, how we generate a clock. Can you tell me how you will generate a clock using Verilog? How many ways you can generate? You can generate using always block. You can generate using a repeat block. You can generate using a forever. Right? These are the 3 ways we can generate the clock. Right? That means suppose initial clock equal to 0 I'm setting. Next, always hash 5 clock equal to not clock. This is how we can generate the clock in Verilog, right? Initially clock is 0 at hash 5 time units. Next 5 time units, clock is not clock. Not clock means if previously it is 0 means it will go to 1. As we are using always here, it is a looping. Okay, it will execute unlimited times. Even whenever you stop the execution until it will loop, right? So again 0, again 1, again 0, again 1. This is how we can generate the clock using always, like that, repeat, like that, forever, right? So like that, in Verilog we can use only this, but in SystemVerilog we can make clocking block for each and every module. Okay, like we will interconnect with our TB to DUT of each module. Okay, which is very work efficiently. That is the clocking block. Virtual interface. Virtual interface means what? In Verilog, how you will do the interfacing with a design and a test bench? Can anyone answer for this question? In Verilog, how you will interface a design and a test bench?
And we will be instantiating the design module in the test bench, ma'am.
Okay. Others? Any answers? Suppose this is my test bench and this is the design code. Whatever the module name I have taken, design name, the design name I will instantiate in the test bench. Okay, this is how I am interfacing Verilog. The design name just I am taking and I am putting the DUT here and making a port list here. I'll take the port list here, interconnection with the test bench and the design. Here how we are doing the interface. But coming to the SystemVerilog, there will be lot of blocks in the test bench, not only single block. Here just we are design and one single block of test bench is interface, like that. But in SystemVerilog there will be a architecture. Every block we need to connect with the design. That's why we will use the virtual interface. I'll tell you those things. I'll tell you clearly. Okay, next one is a mode port. Mode port is nothing but whatever the port list is there, inputs and outputs. Okay, we connect using the mode port in the interface. That is one advancement. Next, program block. Program block is nothing but we will not use program block because it has some of disadvantages, some of limitations are there with program block. But the name is we will use the program block in a SystemVerilog in place of module. Okay, in place of module, we'll use program for some cases only, not all. Like in interface, and in environment videos. Okay, and coming to virtual function and virtual task, solve before X, these are all randomization things. And final block, like initial block, we'll use the final block. Okay, have any doubts here in non-synthesizable constructs? These are the things, main things we are using the SystemVerilog.
Ma'am,
Yes,
ma'am, I didn't get the meaning of randomization.
randomization.
Yes, ma'am.
Okay, in Verilog, how you will do random? You know how to do randomization in Verilog?
No, ma'am.
Okay, see, suppose, okay, how you will generate inputs in the Verilog? How you will generate inputs in the Verilog?
Ma'am, we will assign it.
We will assign directly, like a equal to 0, a equal to 5, a equal to 10 with some time delay. We will assign directly, right? So without assigning directly, suppose if there are so many number of variables, like if there are 10 number of input variable, 20 number of input variable, at all time you cannot initialize like this, right? You cannot do like this. You cannot take all the scenarios. Okay, so at that time we will do the randomization. Randomization is nothing but random A, rand B. It is in Verilog, but in SystemVerilog it is a bit different. Rand C. Like this, we will put according to your size. If you declare A as a 3-bit size or 4-bit size, accordingly it will generate the random values. Okay, it will generate different random values. Suppose A is taking 3 down to 0 size. So between 3 down to 0, between that 16 combinations, it will generate the different random value. Okay, you can put here repeat block. Within the repeat block, if you repeat 10 times, it will generate a random value of 10 times. 10 number of values it will be generated. Okay, this is nothing but randomization.
Okay, ma'am.
Clear?
Okay,
But this randomization is not perfect in Verilog. Okay, that suppose if you do the randomization of a variable a, okay, you will get 2, 2, 3, 4, 2, 6, again 2, 7. Okay, if you get like this, what happens? More number of 2s are getting. If you get 4 times of 2, what about other values? What about other scenarios? The scenarios will miss, right? So many scenarios are missing. So Verilog is not good for randomization. If you take SystemVerilog, in SystemVerilog also it will randomize like that only, but there is a control by using rand-c. Okay, this rand-c is one of the keywords to reduce number of times. Okay, only one time the 2 will be executed. After generating all the scenarios 3, 4, 5, 6, 7, 8, 9, after generating all the scenarios, then only it will go to 2. Still, if size is left. Okay, so that is what if you take a constraint in SystemVerilog, okay, we have more controllability on randomization. That means if you want to generate only 0 to 100, you need only 0 to 100 scenarios, then you can use constraint. If you want to generate only 100 to 200 random values, then you can use constraint. All these things are not there in a Verilog. Especially there is no class-based verification in the Verilog. Okay, that's why we are moving to the SystemVerilog. Clear? Have any doubt?